Welcome to MasterCode. Episode 7, and today we're covering CTF competitions, the best training environment in all of security. CTF stands for Capture the Flag. The concept is simple: solve security challenges, find hidden strings called flags, submit them for points. But what happens to your skills when you compete regularly is anything but simple. CTF competitions are where security professionals develop real practical skills faster than any course, certification, or tutorial can provide. Every challenge is a real technical problem that requires genuine understanding to solve. You can't Google an answer. You can't memorize a procedure. You have to actually understand the vulnerability, the algorithm, or the technique well enough to apply it to a novel problem under time pressure. This forces genuine learning. We're covering all major challenge categories: web, binary exploitation, cryptography, forensics, reverse engineering, and OSINT. We'll go through the tools for each category, the methodology for approaching challenges, the platforms where you should be competing, and the mindset that separates players who make progress from players who get frustrated. Whether you've never competed or you're looking to level up your competitive game, this episode has what you need. Let's get into it. CTF ethics are straightforward but important. These are competitive events that take significant work from organizers to create and run. The community depends on everyone following the rules for the events to remain valuable and trustworthy. The most important rule is to never attack the competition infrastructure itself. CTF challenges run on servers that also host the scoring system, other teams' progress, and the organizer's management tools. Attacking these systems would take down the entire event for everyone, destroys weeks of organizer work, and is genuinely a criminal act since you have authorization only for the specific challenge machines, not the infrastructure. Don't do it. Flag sharing between teams is cheating in the most direct sense. Flags are the proof that your team solved a challenge. Trading flags with other teams for mutual point inflation defeats the entire purpose of the competition and the learning that comes from struggling through to a solution. The scope rule in CTFs is the same as in professional testing: you have authorization to interact with the specific challenge instances provided. You do not have authorization to attack anything outside those bounds even if you discover external systems during your challenge work. Writing up solutions and posting them publicly while an event is ongoing is frowned upon strongly. It allows other teams to solve challenges without doing the work and undermines the competitive integrity. Wait until the event ends. Then write excellent, detailed postmortems. These write-ups benefit the entire community and build your reputation. CTF challenges are organized into categories that correspond to different technical disciplines. Understanding what each category involves helps you decide where to invest your learning time and which challenges to prioritize in competition. Web challenges are the most accessible for people with some web development or web security background. They test the same vulnerabilities you studied in Episode 5, injection, authentication bypass, access control, and common web misconfigurations. The difference from professional testing is that CTF web challenges are designed to be solvable and have a definitive flag to find. Binary exploitation, called PWN in CTF culture, involves taking control of compiled programs by exploiting memory corruption vulnerabilities. Buffer overflows, format string bugs, and heap exploitation. This category requires understanding of x86 and x64 assembly, the C calling convention, and memory layout. It's the most technically demanding category but deeply satisfying when you understand it. Cryptography challenges range from decoding classic ciphers to breaking modern cryptographic implementations with mathematical vulnerabilities. Number theory, statistics, and algorithm-level thinking are all applicable. Forensics involves analyzing artifacts, files with hidden data, network packet captures, disk images, and memory dumps. You're a digital investigator extracting hidden information from evidence. Reverse engineering requires understanding what a program does without access to its source code. You're reading disassembled code or decompiler output to understand the logic and find the flag check. And miscellaneous covers everything else: OSINT investigations, programming puzzles, and steganography. The platform you choose determines the quality of your training experience. Let me walk through the platforms that actually matter and what each one is best for. Hack the Box is the gold standard for practical security training. It provides Linux and Windows machines with intentionally vulnerable configurations. Some machines are active and competitive. Retired machines have official walkthrough guides. The platform tracks your progression and the community is enormous and active. The Pro Labs simulate real enterprise environments including Active Directory domains. Starting on Hack the Box's starting point machines gives you guided beginner content with hints. After that, working through easy-rated retired machines with write-up assistance is the optimal learning path. Try HackMe structures learning into guided rooms that teach specific concepts. Each room combines explanation with hands-on exercises. The beginner to intermediate progression is well designed. If you're completely new to security, start on Try HackMe and move to Hack the Box when you want less guidance and more challenge. Pico CTF from Carnegie Mellon University is the definitive starting point for CTF beginners. The challenges are permanently available, not time-limited. They're designed by professors and students with education as the explicit goal. The difficulty progression from absolute beginner to intermediate is smoother than any other platform. Start here if you've never done a CTF challenge. CTF Time is the community hub, event calendar, team rankings, write-up archive, and the place to find teammates. Bookmark it. pwntools.kr provides excellent binary exploitation progression. CryptoHack does the same for cryptography. Each domain-specific platform provides. How you approach a CTF challenge is as important as what you know. The methodology that successful competitors use is systematic, not random. Let me walk through the mindset and approach that produces results. Reading everything carefully sounds obvious, but most beginners skim the challenge description. The title often hints at the vulnerability category. The description sometimes contains the flag format or specific hints about what you're looking for. The category tells you which tools to reach for. Files provided with the challenge often contain more information than you initially notice. Check every file multiple times as you learn more about what you're looking for. Starting with challenges where you have the highest confidence earns you points and momentum early. In time-limited competitions, those early points matter for motivation and for qualifying for later stages. Save the categories you're weakest in for when you've exhausted your strongest areas. Taking systematic notes as you work is a practice that separates consistent performers from one-hit wonders. Document every approach you try, every dead end, and every partial finding. When you return to a challenge after working on something else, your notes bring you back up to speed instantly. They also become the raw material for your post-event write-up. The time-boxing rule prevents the sunk cost fallacy from destroying your competition. Spending 3 hours on one challenge while several easier ones go unsolved is poor strategy. Set a mental timer. If you're stuck for 45 minutes, switch challenges. Your subconscious continues working on the first problem while you progress on the second. Come back with fresh eyes and you'll frequently see the solution immediately. Web CTF challenges test the same skills as professional web application security testing, but in a competitive context where the goal is clearly defined: find the flag. The attack patterns are consistent enough that knowing them gives you a reliable playbook for each challenge. Source code review is your first action on any web CTF. View the page source of every page you encounter. CTF challenge creators often leave comments in HTML that contain hints, paths to hidden pages, or even flag fragments. JavaScript files associated with the page sometimes contain hard-coded credentials, API keys, debug endpoints, or direct flag references. Before running any tools, spend 2 minutes reading every source file the browser loaded. Robots.txt has saved many CTF players hours of work. Configured to tell search engine crawlers which paths to avoid, it frequently lists paths the challenge creator made interesting. In CTFs, these might lead directly to the flag file or to admin functionality that's supposed to be hidden. Always check it first. Parameter manipulation is the single most common path to web CTF flags. If a URL shows ID equals 1, try ID equals 0, ID equals 2, ID equals -1, ID equals 999, and ID equals admin change role equals user to role equals admin change type equals regular to type equals premium or type equals superuser. The CTF creator hid the flag behind a parameter check. Your job is to find which parameter and what value bypasses or exploits that check. Cookies and headers deserve the same attention. Decode any encoded values. Modify role claims in cookies. Add headers like x_forwarded for. Let me walk through the web CTF commands you'll use most frequently. The robots.txt check is always your first move. Use curl with the silent flag to fetch it without download progress output. When robots.txt lists a path like flag.txt or admin, immediately fetch those paths. In the example shown, robots.txt directly discloses a flag.txt file that returns the flag when fetched. This happens more often in CTF challenges than you'd expect. User agent spoofing bypasses simple access controls. Some challenges check if you're accessing from a specific browser or tool. Add the A flag to curl to set any user agent string. The Googlebot user agent is a common bypass because some challenges restrict access to everything except search engine crawlers for legitimate SEO reasons. Parameter manipulation with curl is faster than doing it through a browser because you don't need to interact with the UI. Change ID values directly in the command and observe the response. In the example, changing ID from 1 to 0 returns admin user data with a flag included. This is a classic error that's extremely common in web CTF challenges. JWT manipulation requires understanding the three-part base64 encoded structure. Decode each section, understand what claims are being made, modify the role or permission claim, re-encode, and submit the modified token. Some JWT implementations accept tokens without valid signatures or with the algorithm set to none. The specific bypass depends on how the challenge validates the token. Always try the algorithm none attack first before attempting anything more complex. Forensics challenges require a systematic analysis methodology because the hidden data can be anywhere within a file or set of files. The approach must be thorough rather than intuitive. File type identification is always your starting point. The file command examines the actual content of the file rather than trusting its extension. Forensics challenges frequently present files with misleading or missing extensions. A file that appears to be a JPEG might actually be a zip archive or a PNG depending on its actual magic bytes. The XXD command displays any file in hexadecimal with ASCII on the right side. The first 8 to 16 bytes of any file contain the magic number that identifies its true format. Knowing common magic bytes lets you identify file types at a glance. PNG starts with bytes 8954E47. JPEG starts with FFD8FF, zip archives start with 54B0304. The strings command extracts all printable ASCII strings from a binary file. Piping the output through grep with the flag format pattern is often all you need for simpler challenges. For longer contests and more complex challenges, look for base64 encoded data in the strings output as well. Binwalk is your primary tool for finding embedded files. It analyzes a file for embedded file signatures and, with the extract flag, automatically extracts them to a subdirectory. Zip files embedded in images, files within files of various types, all found and extracted automatically. Steghide hides data inside image files using steganographic techniques. The extract command with the steganographic file flag prompts for a passphrase. Always try an empty passphrase and the word steganography first. Let me walk through the forensics tool commands in detail. The file command output immediately tells you what format you're actually dealing with regardless of what the extension suggests. For the PNG example shown, the dimensions and color information also appear, giving you additional context. The XXD command piped through head shows you the beginning of any file in hex and ASCII simultaneously. For PNG files you can read the IHDR chunk header in the output and see image dimensions directly in the hex data. The strings command with the capital N flag followed by a number specifies the minimum string length to display. Filtering for strings of at least 8 characters reduces noise from random byte sequences that happen to be printable. grep for flag, CTF, or the specific flag format for the competition, and flags in plain text jump out immediately. For steganography, binwalk's extract functionality is remarkably thorough. In the example output, it shows the JPEG image data at offset 0 and then detects a zip archive embedded at offset 143,211 in hex. The extract flag creates a subdirectory and extracts the zip automatically. The extracted secret.txt likely contains the flag or a key to decrypt further. Steghide with the extract flag and a specified steganographic file prompts for the passphrase that was used to hide the data. The two most common passphrase in beginner CTFs are empty, which you submit by just pressing enter, and the word steganography itself. Steg handles PNG-specific steganography techniques including LSB encoding where data is hidden in the least significant bits of pixel color values. Cryptography CTF challenges range from trivially easy to genuinely research-level difficult. The beginner and intermediate categories follow well-established patterns that you can prepare for systematically. Classic ciphers appear in beginner crypto challenges. Caesar cipher shifts each letter by a fixed amount. Vigenère cipher uses a repeating key to shift letters differently at each position. ROT13 is the specific case of Caesar with shift 13. CyberChef, the web-based data transformation tool, handles all of these automatically. The magic feature in CyberChef analyzes your input and suggests applicable operations, which is invaluable when you don't know what encoding or cipher you're looking at. Base encodings are so common they're almost guaranteed to appear. Base 64 is the most prevalent. It encodes binary data using 64 ASCII characters and is recognizable by its structure and the padding equals signs at the end. Base 32 uses uppercase letters and digits. Base 58 is used in cryptocurrency contexts. CyberChef's from base 64 operation or the Linux base 64 command with the decode flag handles these instantly. XOR encryption is a fundamental operation in many CTF challenges. Single byte XOR means your plaintext was XOR'd with one repeated byte value. Since there are only 256 possible single byte keys, brute force all 256 and the correct decryption produces readable text. Multi-byte XOR requires finding the key length first through coincidence index analysis, then brute forcing each byte position independently. RSA attacks in beginner CTFs typically exploit small modulus values that can be factored directly, or small public exponents combined with small messages. The Crypto CTF toolkit centers on CyberChef for common encodings and Python for anything requiring computation. Let me walk through both. CyberChef is a browser-based data transformation tool that handles virtually every encoding, cipher, and data format manipulation you encounter in CTF challenges. The recipe concept chains multiple operations, decode from base 64, then decode from hex, then XOR with a key, all in sequence. When you encounter an unknown encoding, the magic operation uses frequency analysis and pattern matching to suggest applicable operations automatically. This saves enormous time on encoding challenges. The command line base 64 tool handles simple encoding and decoding quickly without opening a browser. The decode flag processes base 64 input. The XXD command with the reverse and plain hex flags converts hex strings back to binary. These two operations cover the majority of basic encoding challenges from the command line. For RSA challenges, Python's SYMPY library provides factorization for small moduli. When the prime factors p and q of the modulus n are known, computing phi as p-1 times q-1 and then the private key d as the modular inverse of e with respect to phi gives you the ability to decrypt any ciphertext. The POW function with 3 arguments in Python computes modular exponentiation efficiently. For CTF RSA this means decrypting with POW of ciphertext, d, n. If the result is interpreted as bytes it reveals the flag. For challenges where simple factorization doesn't work, the factordb.com website maintains a database of factored numbers and should be checked before attempting other techniques. Binary exploitation challenges ask you to find and exploit memory safety vulnerabilities in compiled programs to extract flags or gain control of remote servers. The foundational technique is the stack buffer overflow. Here's how it works at the conceptual level. When a function is called, the CPU pushes the return address onto the stack. This tells the program where to resume execution after the function finishes. Directly above the return address on the stack is local data including buffers. If a program reads user input into a fixed-size buffer without checking the input length, and you provide more data than the buffer can hold, your extra data overwrites memory past the buffer's end. If you provide enough data, your overflow reaches the return address and overwrites it with an address of your choosing. When the function tries to return, it goes to your address instead of the legitimate caller. In CTF challenges the binary often contains a function called win or get_flag or similar that wasn't called during normal execution but does contain the flag. Overwriting the return address with the address of this function causes the program to execute it and print the flag. Finding the offset, the exact number of bytes between your input and the return address, uses pwntools cyclic pattern. Send a pattern of increasing byte values where each 4 or 8 byte sequence is unique. When the program crashes, the bytes that overwrote the return address tell you exactly where in the pattern the overwrite occurred. Cyclic_find converts those bytes back to the offset number. With the offset known, your exploit is exactly that many bytes of padding followed by the target address packed in little endian byte order. Let me walk through the binary exploitation workflow that you'll use on every binary CTF challenge. Initial analysis before touching the binary with any inputs gives you the information needed to plan your exploit approach. The file command confirms the architecture. Is it 32-bit or 64-bit? Is it stripped, meaning the symbol table was removed, or not stripped? Stripped binaries are harder to analyze because function names aren't preserved. The checksec tool is essential. It shows which security mitigations are present. No stack canary means buffer overflows can overwrite the return address without triggering a guard value. Disabled NX means the stack is executable, which matters for shellcode injection. No PIE means addresses are fixed rather than randomized, which means you can use hard-coded addresses in your exploit. The ideal beginner target is a binary with no canary, disabled NX, and no PIE. Strings output and grep for keywords like flag, win, correct, and the CTF's flag format often reveals the flag directly in static data or shows function names that hint at the win condition. The trace tool, library call tracer, intercepts library function calls including strcmp which compares strings. When you run a binary that checks a password, ltrace shows you both arguments to strcmp, what you entered and what it was comparing against. This immediately reveals passwords and keys without any reverse engineering. The pwntools exploit development workflow starts with connecting to the process, sending the cyclic pattern, letting it crash, examining the crash to find the offset, then building the final payload with the offsets worth of padding followed by the packed target address. Reverse engineering challenges give you a compiled binary without source code and ask you to understand what it does and how to extract the flag from it. The methodology moves from automated analysis toward increasingly manual techniques as needed. Static analysis with Ghidra is your starting point for any non-trivial binary. Ghidra decompiles the machine code back into pseudo-C, which is much more readable than raw assembly. Open the binary in Ghidra, let it analyze, then navigate to the main function. Look for the flag checking logic, typically a function that compares user input against a stored or computed value. The success path leads to printing the flag or a success message. The failure path prints an error. Understanding this structure tells you what you need to provide as input or extract from the program. Dynamic analysis with GDB gives you the program's actual runtime state. Set a breakpoint at the comparison instruction. Run the program and enter any test input. When execution pauses at your breakpoint, examine the registers and memory to see what value your input is being compared against. This often directly reveals the expected input or flag. The symbolic execution approach with Angr automates the process of finding what input reaches a desired execution state. You define the target success state and the tool explores all execution paths to find input that gets there. For beginner CTF binaries without complex anti-analysis techniques, Angr frequently solves the challenge entirely automatically. For strings in the binary, the strings command reveals any hard-coded text including flags, passwords, and comparison values. Many beginner reversing challenges put the flag directly in the binary as a string that strings immediately reveals. The reversing toolkit provides multiple analysis approaches that you apply in order from least effort to most. Let me walk through each command and what it reveals. The file command is always first for the architecture and format information. Strings with the grep filter for flag-related keywords catches the simplest cases immediately. Objdump with the disassemble flag shows the assembly code for the binary. Navigating to the main function and reading the assembly requires some x86 knowledge, but for simple programs the logic is readable. The trace tool is dramatically underused by beginners. It intercepts dynamic library calls, which means any call to strcmp, strncmp, memcmp, or similar comparison functions shows you both arguments. When a binary checks a password by calling strcmp between your input and the hard-coded password, trace prints both arguments right in the terminal. The password is just there. You don't need to reverse engineer anything. Strace traces system calls rather than library calls. It shows file operations, network connections, and other interactions with the operating system. GDB provides complete control over execution. Setting a breakpoint at the comparison instruction, running the program, and examining register contents after execution pauses reveals the expected input. The x/s command examines memory at a register address as a string, which displays the expected comparison value directly. For more complex reversing challenges, Ghidra's decompiler view provides readable pseudo-C code that makes the program's logic accessible without deep assembly expertise. Combine Ghidra for structural understanding with GDB for runtime value inspection and you can analyze almost any beginner or intermediate reversing challenge. OSINT, Open Source Intelligence, CTF challenges test your ability to find information that's publicly available but not immediately obvious. These challenges reward patience, creative thinking, and familiarity with the tools that aggregate public information. Reverse image search is one of the most common OSINT techniques. You're given an image and asked to identify a location, a person, or an event. Google's reverse image search and TinEye both find other locations where an image appears online. Even if the image itself doesn't reveal anything, finding other instances of it provides context. The exiftool command extracts metadata from image files. Camera GPS coordinates, creation timestamp, camera model and settings, software used to edit the image, all potentially present in the image file itself. EXIF data has solved many OSINT challenges immediately. Username investigation using the Sherlock tool searches hundreds of social platforms simultaneously for accounts with a given username. People use consistent usernames across platforms. Finding the target's accounts on Twitter, Instagram, Reddit, GitHub, and LinkedIn often reveals the information the challenge is asking for. Geographic identification from images requires attention to background details. Street signs, license plates, architectural style, vegetation type, vehicle types, and power line configurations all vary by region. The direction of shadows indicates compass direction and time of day. These details together can narrow a location to a specific city or even street. The Wayback Machine archives historical website captures. When a challenge asks about information that was previously public but has since been removed, the Wayback Machine often has a snapshot. Your CTF toolkit is a specific set of tools that you install, configure, and maintain for competitive use. Let me walk through each one and why it's essential. CyberChef is the Swiss Army knife of CTF tool use. It handles every common encoding, cipher, and data format in a drag-and-drop web interface. The key feature is chainability. You stack operations to decode layered encodings. The magic feature attempts automatic detection of applicable operations. Run it locally for offline competitions using Docker. Know it well because challenges that would take 20 minutes of command line work take 30 seconds in CyberChef. Ghidra from the NSA is the standard free alternative to the expensive IDA Pro decompiler. It handles x86, x64, ARM, MIPS, and dozens of other architectures. The decompiler produces pseudo-C from machine code that's often readable enough to understand program logic directly. Install it on your CTF machine and get comfortable with navigation and searching for interesting functions. pwntools is required for binary exploitation. Without it, exploit development involves manual byte manipulation and repetitive boilerplate. With it, the framework handles connection management, pattern generation, address packing, and interactive session management. StegSeek is a fast steghide password cracker. Instead of manually trying passwords, it works through word lists at high speed against steghide-protected files. Many CTF steganography challenges use common passwords that StegSeek finds in seconds. Volatility is the memory forensics framework for challenges that provide RAM dumps. It extracts running processes, network connections, registry hives, and file. The decision between competing as a team or solo significantly affects your competitive experience and your learning outcome. Both have genuine advantages and the right choice depends on your goals. Team competition allows your group to cover multiple challenge categories simultaneously, with each member specializing in their strongest area. Your web expert works web challenges while your PWN expert works binary challenges in parallel. This specialization lets a team solve more total challenges than any individual could in the same time. Knowledge transfer happens organically. When you're stuck and a teammate sees the path, you learn from watching their approach. The coordination overhead is real though. Agreeing on methodology, avoiding duplicated effort, and managing a shared repository adds friction. Finding good teammates is itself a challenge. CTF and Hack the Box communities both have team formation channels. Solo competition is the maximum learning experience. Every challenge you solve required your individual knowledge and problem solving. There's no teammate to ask for a hint. The struggle is complete and the skill building is complete as a result. Solo success on a difficult CTF machine is a genuine accomplishment that demonstrates real individual capability. Many employers and interviewers look at CTF performance specifically to assess individual technical ability. Beginners often benefit from starting solo to identify their gaps, then joining a team to learn from stronger players. Advanced players who have identified specific weak areas sometimes return to solo competition in categories where they want to force deep skill development. Both modes have value. Use them intentionally. The learning path for CTF skill development is well established because the community has had decades to figure out what works. Let me give you the specific progression that produces the fastest results. CTF is your mandatory starting point if you've never competed in a CTF. The challenges are available year-round and never time-limited. Carnegie Mellon's computer security professors design them explicitly for educational value. Work through the beginner challenges in each category. When you get stuck, the hint system provides nudges without giving away the solution. Complete at least 50 challenges before moving on. TryHackM's CTF learning paths provide guided instruction for specific CTF skills. The rooms explain techniques, then have you apply them immediately. The web hacking, cryptography, and OSINT rooms are particularly relevant for competition preparation. The guided format is valuable early in learning before you've built the mental models needed to approach challenges independently. Hack-the-Box retired machines with official write-ups let you compare your approach to the solution. Solve the machine independently first. Note everything you tried. Then read the official walkthrough and identify exactly where your approach diverged. This gap analysis is the most targeted learning available. CTF's write-up archive is the best resource for understanding how top players think. After each competition, teams publish detailed solutions to every challenge they solved. Reading these write-ups exposes you to approaches and tools you'd never discover on your own. Make it a habit to read write-ups for the top-rated CTFs even when you didn't compete. Competing in live events is the final requirement. The time pressure, the uncertainty, and the community experience of live competition. The mindset with which you approach CTF challenges determines how much you learn and how well you perform under competitive pressure. Let me share the thinking patterns that consistently produce good results. Every element of a CTF challenge exists for a reason. Challenge creators invest significant time designing puzzles where every detail is intentional. The challenge title often encodes the vulnerability category or the specific technique required. The flavored text in the description may contain encoded hints or pointers to relevant concepts. File names and provided archives are sometimes significant. Server responses might include unusual headers that hint at the technology stack. Train yourself to notice everything and ask why it's there. The flag exists and is reachable. This sounds obvious, but it's psychologically important when you've been stuck for an hour. The organizers verified that their challenge works and that the flag is achievable before publishing it. You're not searching for something that might not exist. There is a definite path from your current position to the flag. Your job is to find it. This certainty eliminates a category of frustration that plagues beginners who doubt whether they're on the right track. Documenting your attempts turns struggle into progress. When you've tried 5 approaches and none worked, your notes tell you you've eliminated 5 wrong paths and gotten closer to the right one. The documentation habit also produces the raw material for post-event write-ups, which build your public reputation and help other learners. Fresh eyes are the most undervalued competitive resource. The cognitive phenomenon of fixation means you can stare at the same wrong assumption for an hour without recognizing it as wrong. Stepping away breaks that fixation. Return to a stuck challenge after working on anything else. Let me give you an honest assessment of the different skill levels in CTF competition so you can evaluate where you are and what your next development targets should be. Beginner level is where everyone starts and where the most foundational skills develop. At this level you're working through CTF and TryHackMe rooms. The web challenges you can solve involve reading page source, checking robots.txt, and basic parameter manipulation. For encoding challenges, base64 and hex decoding are your primary tools. For binary challenges, you can use strings to find flags that are stored in plain text. The goal at beginner level is to get your first 10 flags and build confidence that these challenges are solvable. Intermediate level is where most of this episode's content lives. You're solving hack-the-box easy machines without walkthrough assistance. Web challenges include SQL injection and XSS exploitation. Binary challenges include basic stack buffer overflows without sophisticated mitigations. Crypto challenges include XOR cracking and RSA with factorable small moduli. Forensics includes binwalk extraction and steghide analysis. At intermediate level you're competitive in beginner track events and can contribute meaningfully to team competitions in CTFs with a broad difficulty range. Advanced level is where competition placement becomes significant. Medium hack-the-box machines, ROP chain exploitation for bypassing non-executable stacks, format string vulnerability exploitation, custom cryptographic analysis, and kernel exploitation basics. At this level you're consistently placing in the top 50% of competitive CTFs and your individual skills are demonstrably professional grade. Assess where you are honestly and target the next level systematically. Episode 7 complete. You have the CTF framework you need, challenge categories and how to approach each one, the essential tools for web, forensics, crypto, and binary, the platforms where you should be practicing and competing, the systematic mindset that produces consistent results, and an honest progression map from beginner to advanced. Here's your immediate action item: create an account on PicoCTF right now and solve 10 challenges before this week is over. Not 1. Not 5. 10. Start with web or forensics challenges at the beginner level. Find your first flag. Experience that moment when a challenge that seemed impossible suddenly clicks. That experience is what every competitive security professional is chasing and building from. Episode 8 covers bug bounty hunting in depth. This is the discipline where you apply everything learned in this series to real production applications and get paid for finding real vulnerabilities. We're covering program selection strategy, how to identify high-probability targets, professional report writing, common bug bounty finds, and how the top earners approach this work systematically. If you want to make money from security research legally, Episode 8 is the one you've been waiting for. Subscribe so you don't miss it. See you there.